I wanted to thank everyone again for joining us today. It is our 16th episode of our Graph Gurus webinar series for developers. And today we are covering how to build a hyper-personalized recommendation engine using TigerGraph. My name is Emily McAuliffe, and before we get started, just a few housekeeping items that we're going to go over before. All attendees are muted right now, so if you need to reach us, you can use the chat feature just to reach the panelists, or if you have specific questions about the content, we would ask that you use the Q&A feature built into Zoom to ask questions. You can go ahead and send them at any time. And we are going to record this webinar and send it to you via email. And I think in a couple minutes I'll be able to share the slide deck with you so you can follow along. So I'm going to go ahead and introduce our speaker today and pass it off to him. He's actually coming to us from the UK today, and Richard Henderson will be doing the Graph Gurus presentation today. So I'll pass it off to you, Richard.
Thanks, Emily. Hopefully you can hear me. So today we're going to talk about recommendation engines. This is something I've built a number of these over the years, and before I came to work for TigerGraph, so I've very much bumped into a lot of the issues that we see with recommendation engines, and I want to show you how things have developed over the past few years. So I think the first thing to do is look at where we've come from. So something which we're kind of calling recommendation 1.0, and this is really what we call collaborative filtering. And the idea of this, which if you've ever looked at any graph websites of any of products, they will talk about this, is the idea is that when a customer buys a product or is looking at product, you look at what other people have bought at the same time when they were looking at these sorts of products to make recommendations. So if I buy a particular product, say, and it's a battery-powered product, then you'd expect batteries to be recommended as the next thing so that you get some, because other people, when they bought that product, they also bought batteries. Now, there are some issues with doing this. It works very well, but these issues tend to come up time after time, and particularly when you're trying to attract new customers, there's a bit of a problem. So the problem with new customers is that you don't actually have any purchase history, so it's very difficult to know which other customers are similar to them, nor indeed what other products might be useful to recommend to them. And this is what we call the cold start problem, which is when you're starting without any history of a customer, and it's very difficult to know what to recommend to them. The other problem is that when people look at products, they'll tend to look at a lot of the same product before suggesting before buying the one that they actually like. And so what can often happen is that if you are in the market for a particular product, say a light, and you buy that product, you then find that you are then continuously recommended more lighting products at that point, because those lights tend to group together in the product database. And so this problem of constantly being recommended identical products just starts to irritate the customer, which is obviously going completely against the idea. And then finally, if you've got a large number of products or a large number of customers, then doing this sort of join approach to doing things, it's just very, very difficult to scale. Particularly as soon as you get up to anywhere near 1 million customers and you're getting anywhere near 1,000 products, then suddenly the size of the queries that you're having to deal with becomes enormous. So dealing with very large product bases is a very useful capability. You don't want things to slow down. You need a recommendation engine to be very snappy at all times, particularly during peak periods like sale periods and things like this. So if we're going to look at what would recommendation 2.0 look like, one of the first things we can look at is what are they saying in academia about recommendations. And Robin Burke in 2002, he did a survey of all of the papers that have been written on recommendation engines and how they should work. And he found that there were basically 5 types of recommendation engine available. Of those, we've already talked about the collaborative one, which is the first one, but also there's other types of recommendation it can be based on. It can be based on content-based, and this is based on the idea of features, of item features, and we'll see this later when I talk about the engine that we're describing. Another one is demographic. So Demographic implies that if you have a brand new customer, then potentially you can assign them to a demographic, and then therefore you can work out a recommendation immediately at the beginning, even though you may not have a history for them. So these are all useful. Utility functions and utility-based, this is where not only do you talk about the features of an item, and when I say features, it can be things like what sort of environment that you want to use a particular item. It can be its color, it can be what it's used for, its function, it can be what decoration is it. So for example, certainly on our website, we talk about a Batman pencil case, for example, as having a number of features that it can then use to expand the scope of a recommendation. And that's the utility-based side of things. And finally, there's knowledge-based, which is how do you not only take the features of items, but then expand that into working out what class of items there are. And when we talked about the Batman pencil case, we think, well, what context does that generally rely on? And that relies on, say, for example, going back to school. And so there are certain contextual elements that you can apply to this. And this is something that comes up over and over again, is to remain engaging with the customer. You really have to be sensitive to their context of why they're buying at the moment. And therefore, you can use that to inform your recommendation system. So if we're going to go technically as to what good looks like when you're in order to be able to do these other styles of recommendation, then there's various things that you need. And this is going quite deep, but I will explain as we go along. First of all, we want things to be very real time. And so in order to do that, you need to be able to maintain data very much up to date. And this is where you need the ability to streaming load of data. A lot of the systems that I've used in the past were essentially batch analytic processes, and so therefore relied on overnight or hourly or some periodical loading of data before they could actually use that data. And the problem with that is that essentially you have prevented yourself from being able to do much in real time. So you absolutely need that streaming load to go on top of the batch loading that you would normally have anyway. Non-blocking updates is important. If you are going to be streaming load, if you are going to bring in information continuously as you're going, then you need to be able to update that data without slowing down your normal query path. So this is really important, that as well as real time, that you have this non-blocking updates. And then finally, analytics directly in the graph is another useful thing. What does that mean? What that means is that you can modify the things like the feature weights in your graph as the data is being loaded. It's all very well. If you can real-time enter data, that's all very well. But if you can't then also process it in near real time, then you're not going to get the advantage at the front end, which is where you need it. And finally, you want a fast and scalable query engine, which is kind of a given, but we've talked about wanting to be able to support very high scale. So being able to, for example, deal with sale time, deal with peak periods. And the only way you're going to do that is if you have something that in the first place is fast enough to be able to handle the load at reasonable cost. So you don't need 1,000 machines in order to handle your peak period. But also you want it to be scalable so that you can start off small if you want to, and then you can, using exactly the same model without having to modify anything, without having to worry about your technology running out of steam, be able to scale it to whatever size that you want to have. Now, obviously, this is a TigerGraph presentation, but I think what I want to say is that actually when we were looking at the original design of the product, these were very much the drivers that drove the product. So TigerGraph has been specifically designed to address exactly these kinds of requirements. And indeed, some of our initial customers wanted a recommendation engine. And so this has heavily influenced our product. So generally, if you're building recommendation engines, TigerGraph is pretty much the perfect graph analytic platform for that. Here I want to show a picture of the architecture of what that actually looks like. So this is kind of getting into the guts of it. Now note, this is just an example of a recommendation engine. It's quite simplified. It's deliberately simplified so that it can present on the screen. I think if you were ever going to build this yourselves, no doubt it would be much more bespoke, much more crafted towards your business. But hopefully this will at least illustrate why TigerGraph is good for this kind of activity. So overall, one of the things to notice is that an awful lot of the processing from load all the way to the query at the end is done within, can be done within the TigerGraph database. And this is an important feature. This is having analytics in the database allows you to do this. And that means that rather than having to have 3 different types of data scientists, plus a DBA, plus somebody who understands graph, plus somebody who can do the web API side of things, you can actually do this with a single resource in TigerGraph, because we can provide that all the way from the point of ingestion of data through analytics and through to the real-time querying aspects of this, all done in the one, all done real-time end-to-end. I'd like to just go into a little bit more detail about the parts of this, just so you can understand which parts of the product actually can perform this kind of activities. So on the left, we have the loading. So how does data actually get into this system, and what model do we use to actually have that? So if I just zoom this out, what you can see here is we have this, all these loading features are available to you. On the one hand, you have your normal batch loading, because you're still going to have a number of products, a large catalog of products, and that's static data. Similarly, purchase history and context coming from the purchasing side. There's preferences. So when you have a catalog, since we're talking about adding features to products, that's something that you would do offline and is probably done as part of your catalog generation process, or indeed part of a batch machine learning process, which I'll mention much later. These are all things that would essentially, once you've created these models, they would be loaded as part of your overnight process. And that's your parallel batch loader. TigerGraph has a particularly fast parallel batch loader, mainly because we need to be in a position where we can load millions of rows of data in a reasonable amount of time. And so we have created a batch loader that allows us to load all of that data in parallel very, very quickly. And indeed, we have a loading language that is used to do this. It makes it very, very easy to load large amounts of data from external systems. What we also have is this real-time update capability, which we talked about earlier. This is usually done via a messaging backbone. So for example, we provide a Kafka sync. If you know anything about messaging products, Kafka is an open source product that is extremely good for creating large-scale distributed messaging platforms. And that's really useful for getting events into the system. And this is when we're talking about these real-time updates, that could be things like inventory. It could be additional and new products. It can be any change to the existing model as it stands. And indeed, you could do your entire model with just real-time updates. You wouldn't necessarily have to do any parallel batch loading at all. You could keep that purely for backup and restore purposes if that's what you wanted. It's very powerful, very fast, and it uses exactly the same loading language that we provide for the parallel batch loader. Exactly the same techniques are used for the streaming loader. It essentially treats it as one giant file that never ends. So it makes it, again, we're trying to make it easy to consume these sorts of advanced capabilities without having to learn too many different skills in order to do that. If we look at the model is a very direct description of what we described. So we have demographics at the top. So this is so that when you have a new customer, in principle, and indeed in practice, you can immediately assign them to a demographic based on some small amount of information that you can work out from asking them questions. It's an easy way of doing it. And generally, when people are engaging with an application, they don't mind answering 1 or 2 questions if you tell them why. It's so that you can help recommend products to them. And what this does, it essentially gives you a default set of preferences associated with a customer. For example, if a customer is a family person, then it may be that they're going to be looking for products that are associated with families. If they're a single person, they're going to be looking for things that are associated with single people and so forth. So these are very broad demographics that you can use to just get a first cut at recommending things to them. And that allows you to populate your screen without just putting random stuff up on the screen. It gives you at least a starting point. And it's something that you can develop collaboratively with the customer. We still have history there, and we still have the history of purchasing the products. This doesn't go away. This is in addition to your existing collaborative stuff. So if you've got an existing recommendation engine, or indeed you're very, very comfortable with using the collaborative technique as a way to go, then this is still in the model with a history of purchasing of the product that a customer does. And what we can do is we can use that to bring people away or derive their real preferences as we understand their purchasing history. And this is important. You don't want them to be stuck in the demographic mode. You want to add in that historical, personal view. And then when we talk about hyper-personalization, this is definitely one major pillar of that, is this ability to steadily refine your recommendations so that people can see where they're going. The products and attractions here, I've used holidays as a simple example here, but obviously it could be any product. You can see there's a link between the products and the features of that product. And this, again, one of the lovely things about Graph, which I think is almost its most obvious secret weapon, is that you can model things just as they appear in the world or as they appear conceptually in your mind. The logical structure, you don't need to normalize anything. Normalization is unnecessary. You're not having to bend yourself to suit the database. Instead, with a graph, you have this rather nice capability to write down what you want something to look like or how you understand it, and you can pretty much express it directly in the graph. So here we have the links between demographic and features, which is really the preferences. So what are the preferences for particular features that anybody in a particular demographic has? And then below we have the products, which then the products themselves, they're the features of those products. And so again, this model is very, very simple. We've got one small part of the model I put down here, which I'll just mention it quickly, but as it doesn't really appear much else, is this partner side. One useful approach for this is if you've got, say, a sale on or something like that, then or you're white labeling out to other customers, then partner relationships become quite important. And so you directly model them in the graph. If that's what you want, and you want to be able to modify your catalog or change your pricing or provide coupons or loyalty or any of that kind of partner activity, that's something that you can just add into the graph as you need it. You don't have to have it, but when you do need it, you add it in, and there's no major change to your structures. So that gets away, again, which is the other problem you often have with relational data stores, is you can build it perfectly for this week, but once you get to next week and you have to change it, that becomes a really difficult process involving a lot of migration. In graph databases, because it just looks like the world, effectively you can avoid a lot of that migration pain. So moving along here, we have the analysis. I talked about analytics in the database, and this is an example of the sort of analysis that you can do. So again, zooming in, here you'll notice that now customers have preferences for features, and really you want to be able to modify the customer preferences according to what they have bought and what more you know about the customer. It could be as simple as asking them which of these things do you prefer the most and get them to reorder it, and that allows you to modify the features. So effectively you can in real time take their feedback as it arrives, and you can actually embed it into the model directly without having to wait at all. And this gives people the sense that the tool is really working for them rather than just working for the vendor. It gives you a really nice, engaging capability. And this is where we're getting into the mode of not just personalized, but hyper-personalized. The idea that the recommendation system itself is actually personalizing itself and adapting itself to the user as they use the system. And this is a very important part of engagement models when you're looking for these very high-touch engagement models where you want to be the first point of contact. So instead of going to Google, you want them to come to your app when they're thinking about holidays or any particular class of product. And getting Google out of the middle has got to be the ambition of pretty much everybody. If we can get to the point where people will come to you first, so as I say, in this type it's holidays, it could be insurance products, it could be financial products, it could be any product associated with a particular vertical, then actually you're getting to the point which is we're seeing in the real world, where high touch, high engagement, very niche products or very specific products where people know exactly where to go for it, then at that point, this kind of activity is what you want, this ability to have this real-time responsiveness in the preference system. Moving on, we get to the main engine. This really puts the final touches on this kind of recommendation system. Again, zooming in, this comes in two parts actually. The first part is how do you deal with such a massive, when you have a very large number of products, where the products are very contextually, where the context makes a big difference as to which products you want to show, then this is the first part of this, is the filtering of the product set. So you've only got products which are relevant for a particular context. And then after that, how do you then order those products and present them to the user? So that's the second part. So I'll zoom in on the first part a little here. So this one is the filtering. And the idea here is, you can see there's this green arrow on the left. If I go back, you can see where it comes from. It actually comes from the recommender application. This is getting that information. Typically, if people are using mobile applications, it can be the app itself on the front end, which is determining context. And context can be things like, what temperature is it? It can be, how fast is this person moving? What time is it wherever they are? What location are they in? But what time is it there? But also, what is their immediate surroundings, their immediate location? It's that kind of extremely live context of the customer that you really want to get into the system so that you can filter your product set. Here we have the product. So, for example, imagine somebody is in Valencia and they're using your application and they want to know which restaurant they want to go to in order to eat that night. The first thing you can do to make it possible to have a lot of products, and we have holiday customers where they have attractions and features from all around the world. I mean, literally across the entire globe. So how do you cut that down so that you can still have this very responsive product? And the obvious one is, here we've got two pieces of context we're using. One is the location, and that's immediately cuts it down. So here we're saying they're in Valencia. So if they're in Valencia, that's fantastic. You know exactly where they are. There's no point in giving them products associated with different places like Madrid or London or New York. There's just no point. Stop doing that. Immediately you can cut that out, and that's going to cut down your product set by an enormous amount. And this is how efficiency is gained, by not having to trawl through your entire catalog, but stick to the things that actually matter. Similarly, what's the weather like in Valencia? What time it is? We're saying it's sunny in Valencia, and the time, it's in the period between 6 o'clock and midnight. So this is a particular period when you might be interested. And of course, that is what's going to qualify the different restaurants that you might want to go to. It may be that, for example, breakfast bars are going to be useless between 6 and 12 because they're generally going to be closed. Equally, restaurants that open in the evening, then they should be part of the list of products which you're going to show. So you can see how by adding context, immediately you're not just showing people noise and expecting them to filter it for you. You're getting this sense of a very human touch being applied to the set of recommendations, and therefore you're getting this much more engaged approach. So the next step is ordering, and this is where preferences come in. So the list of products you get is still going to be a very big list. It can be maybe thousands of products. And the idea is, okay, we only want to present the top 5, top 10, whatever is the list according to the user wants, and we want to give it in the order they want. So my preferences may change. If I'm in a hurry, then really I'm interested in the things that are closest. If it's a special night out, then I might be prepared to travel much further in order to have a more special meal. And so it's very important that we can customers are given the option to actually make those choices so that you can then order the list appropriately. So the first thing we do is we use their feature preferences to say, what sort of things do you prefer? In what order do you generally prefer things? And this can be taken from their history, or it can come from them explicitly stating what their preferences are, or indeed it could have been inherited from demographics, as we talked earlier. Once we've gone through those features, we navigate, and this is a classic graph traversal, we navigate from the customer to the features and the features to the products. But the interesting thing here is that we can do an analytic calculation immediately on this entire list of products, and we essentially score those products. And there are various ways of doing this. If you're into graph theory and things like that, you'll hear about cosine similarity, Jacquard similarity, that all indeed just customer stated preferences. There are a number of ways in which this can be done. And the great thing about TigerGraph as an engine is because we can do those things in the graph without delaying the query, it means that it gives you a lot of choices. And indeed, some people are looking at ensemble approaches where they actually use multiple different scoring regimes and we use the one which they feel is likely to be the most accurate. So now we've got this list of products. And what I'd really like to do is actually show you a little demo of this in action, if I can. And this is where I have to hope that everything is working in my favor. So if we go into Graph, this is GraphStudio. This is a tool that we supply as part of the product. And the idea is to make it very easy to inspect and design models, to be able to load models, and indeed to be able to explore the data which is within those models. It started off purely as a development tool, but we're finding that as we add features that people are using it more and more as part of their development process, and also to some extent being able to show users. So it allows you to do things like create minimum viable products just using GraphStudio and then taking the feedback in order to build the complete application. And I know it's on our roadmap to continuously enhance this capability. Here we have the model, and I hope you can see that actually it looks very much like the picture that we showed earlier. We've got demographics at the top, we've got customers associated with demographics, we've got the customer's history of buying products if it's there, and then you can see these features which lie in the middle, and the product, these are product features. So the features of the product, demographic relate to features. This is the general preferences associated with the demographics for a particular set of features, and customer features, which is what we really care about when we're actually doing the querying. And then down the bottom, we have the context. And this is the important piece. This is what gives you that real-time responsiveness. This is what takes it beyond standard personalization and into the hyper-personalized regime. If I move tabs here, and this is live, so hopefully it will work when I press the button. This is the data I've loaded. This is obviously a very small data set, because if I put in a large data set, it would just be too difficult to see. But if I may, I'll just talk through this a little bit. The red dots on here, these are the customers. These are which we talked about, and we have 3 customers here. We have Alice, Bob, and Archie as the 3 customers associated with this. And those customers are associated with a particular demographic. And if we look at the customers specifically, there's these edges which I've got affinity written on there. Let's see if I can pull one up here. So this is the affinity. And what that's saying is that Alice has a particular preference, score 12, for French food. So the features here are really about whether it's French food, Italian food, or German food. And here we can see that Alice, she likes French food. She's got an affinity of 12, which is relatively high. -3 for Italian. She really does not like Italian, so she prefers not to. She prefers Italian food to be far down the list, and she's kind of okay with German food. So that immediately you can see how that could be used to order products if we go across into the products themselves, which are restaurants. Here we have French food, so Andre's Snails. We have Luigi's Pizza, which is Italian food, which clearly would be something that she would then not like so much. And then we have Hans and Gretel, which is a pure German food restaurant. And then at the bottom, we have Bobby's French, German, and Sausage Shop, which the point of that being that you could have multiple foods at the same place. So this is, let's call it a rather odd fusion cuisine, if you like, which is it's both French food and German food in one restaurant. Each of these features is weighted. Now here I've left all the weights as 1, but what that allows you to do essentially is to provide overall global scoring of particular features associated with a restaurant. So we could have, if we wanted to, have said that Bobby's is actually 90% German and 10% French, in which we could apply the weight. But that kind of doesn't make sense in this context. But for particular products, that may make a big difference. And when we talked about machine learning and where machine learning comes into this, machine learning is often used to adjust these weights. It allows you to, without affecting the preferences of customers, essentially adapt the features of your products to the way that it's being bought, which essentially tells you what the features are. And this is a very interesting area. Netflix had the $10 million prize some years ago, where they tried to get their recommendation engine that was better than theirs. They said if your recommendation engine was 10% better than theirs, then they would give you an amount of money. I believe it was $10 million. And the way the winners won was by doing something very much like this. What they did was they worked out what the features of the movies were. They worked out what the groupings of the customers were into demographics. And then for each of the movies, they had to work out just how good the feature weighting was for these particular things. So, for example, they had movies, it could be a comedy movie, but it could also be a comedy horror movie. Well, which is it? Is it a comedy movie or a horror movie? And so what they said was, well, it's both. So we can weight them in different directions, and that can give you a much more refined way of predicting what a customer is going to like, which is really the essence of recommendation engines, is trying to predict what people want to like. And this approach has some very good basis for working. Having said that, the Netflix approach obviously didn't use graph to do this, because they didn't have a graph available at the time. They used an awful lot of data science, Python, and inversion of matrices. The math is quite interesting if you're ever interested in looking that stuff up. But actually, it corresponds almost directly to what we're doing here. Finally, on the right, I've put the context pieces, and I've got two different sorts of context here, just to make the point that context is something that could be of any sort of context. Here I have two types of context. One is a time type context, which really, I said that some restaurants are open in the morning and some are in the evening and some are open very, very late at night. And so we have these four time periods. We have after midnight, extremely early in the morning, which it turns out only Luigi's Pizza is open that early in the morning. Then at breakfast time, both Luigi's and Bobby's is open. And then once you get to lunch and dinner, everybody's pretty much open for lunch and dinner. And so this, again, you can see how directly this is saying, and this is directly mapping the context into your products. And this goes back to the idea that a graph model is something that very directly reflects the way you think about things, or it should, and it can operate upon that very, very successfully without having to normalize. Down at the bottom, we have a different sort of context. And here we have the weather context. We talked about the weather. We have both good weather and bad weather. And I think the interesting point here is that all of the restaurants are open in good weather, which isn't terribly surprising. But Luigi's Pizza, actually, that could be an outdoor restaurant, in which case, in bad weather, you don't want to see Luigi's Pizza. And again, you can see if you don't see it, it doesn't have a link. So in bad weather, there is no link to Luigi's Pizza. And again, very intuitively, you can get the sense of, okay, so that means that Luigi's Pizza shouldn't turn up in a result if the weather is bad. So let's run a query on this. For those of you who are new to the product, this will be the first time you'll have seen the language. We said that we had a language for this, and here it is. It probably looks a little bit more complicated than it really is, but fundamentally, the thing to notice in the language is that, first of all, it's just a stored procedure. If you're used to using Oracle or SQL Server or any SQL databases, then it's very simple, very similar to that. You have a product, in this case, you have a procedure name, in this case, it's rank product. It takes a bunch of arguments, so these are the parameters that it takes. It has variables, it does work, and the work is expressed really by repeated sets of these queries. And we've very deliberately made it look a little bit like SQL. The idea being that that people who have come from the SQL world or are used to the SQL world, which is pretty much everybody, they can see what we're trying to do. It operates in pretty much the same way and gives them a rather reasonably easy on-ramp into the whole world of graph without it being particularly painful. This is something, obviously, we have competitors in the market. This is something that we think helps us with competitors in the market. Generally, we find our competitors fall into two camps. Either they have an extremely complex language, which is completely different to anything that anybody's ever seen before. And that, of course, creates a problem. When you're trying to use it, it makes it quite difficult to use, because you need people with special skill sets in order to be able to get there. And that can take a long time to get there. Yeah, or the language they give, it doesn't allow you to do analytics. It allows you to do just this select. That's all it does, select where. which is fine. But when you want to do things like update the weights of products or do analytic calculations, have this real-time responsive analytics in the database approach, which we are proposing, then those kinds of very limited languages, unfortunately, aren't going to help you. And particularly in graph, you really need that. And so what they force you to do is either to drop down into their underlying language, which they're written in, Java or similar, or you have to start bolting on for more products around the outside, like Spark and things like that, just to get some fairly simple features like aggregation, like sums, like the ability to operate upon the graph using what are considered pretty standard graph algorithms. Certainly what we've talked about today would be very difficult to do in those languages, whereas here we're doing it in one shot. So just to run a query for you, customer one, that was Alice. We're saying, imagine she's in Valencia, it's in good weather, it's T2, that's breakfast time in the morning, and we want to see the top 5 results. If I run that query, then immediately it returns 2 results, which here is P2 and P4. And what I'll do is I'll drill into those just so you can see what that means. So the top of the list is Bobby's French and German sausage shop, because it turns out that if it comes to breakfast for Alice, she gives a score of 12 to them, and that's because they're both French and German. She thinks that's great, she loves that, and so that's what she wants for breakfast. Meanwhile, just in the background there, Luigi's Pizza, but as we remember, Alice really doesn't like Italian food, and so she wants to see that further down. Now, if that was all there was, and if she was prioritizing distance, then it may be that actually Luigi's Pizza, you'd still want to put it on the list. So the idea is not to exclude it completely from the list, but use this to order the product. Now, if you remember, the thing about Luigi's Pizza was it's outdoors. So let's say we change the weather and we go from GW good weather to BW bad weather, and we run this query. And crossing my fingers, there we go. So we can see that now that we've understood the context, now Luigi's Pizza has gone away. It's just not being used anymore. And so therefore, but we don't want to put it on the list, because if she thought she wanted something that was nearby, and so Luigi's Pizza would otherwise have turned up on the top of her list, but actually if she got there it was closed because the weather was bad, that's going to be a very bad experience. So applying this sort of contextual filtering allows her to actually avoid that. And that's pretty much all I've got for the demo side of things. But essentially what we're going to do is at some point we want to actually put this up on our website so you can play with it and you'd be able to look at the code. But certainly this is pretty much available as is. And of course, if you want us to, I'll happily come to you and actually go through it and show it to you. And there you go, that's the demo. So if I can get back into presentation mode here. So a quick summary before we move to Q&A. So we talked about the common challenges of recommendation and said that they're pretty well known, and they've been known for a long time. So we're not inventing anything here. What we're really saying is we provide an engine that allows you to move beyond standard collaboration approaches, which you would otherwise be limited to if you were using, say, relational data stores or more limited graph technologies. The theoretical solutions to these challenges have also been understood for some time. So again, there's not a huge amount of deep thinking. I've shown you the model. The model is really quite simple. You can make it a lot more complicated if you want to, but why reinvent the wheel? This is something that is available. It's something that you should be able to build and use quite quickly. And the other thing is that we've made the point that you can add on. So you can start with collaboration and then start to add in these other approaches as you want to and as is appropriate to you. So this isn't a giant change of the world here. This is an incremental enhancement of capability. Originally, the practical solutions for this were built, but they required enormous resources to build and maintain. We're talking Google scale, we're talking Amazon scale, we're talking Alibaba scale. These are the people who could afford to hire all the PhDs and to get all the skills in order to do this. What we have done at TigerGraph is take all that and encapsulate it as a graph engine, which was designed from the ground up to respond to just these kinds of challenge. And what I've shown you is, I think, a reasonable toolkit to at least get you started to build this stuff, and you could you could take that and you could execute that exactly as is. We'd give that to you. You're totally welcome to take that code. Obviously, we'd advise you on making that appropriate to your particular business. And that is the key point here, is that with hyper-personalization, the idea is that you have something that responds to what you're doing and responds to the needs of your customer. Equally, we think that TigerGraph it is just an engine, but it's a very sophisticated engine. And because we're based on graph, we believe that that makes it easy to make it your recommendation engine and make sure that you reap the benefits that you want. Okay, on to Q&A if we've got any questions. Victor, are you there for this?
Yeah, so this is Victor Lee, product manager at TigerGraph. I've been listening to Richard give his great presentation. I want to thank him on that. We did get one question from a listener, and he's basically just want to make sure he got the basic point. So I'll read it out and see if you want to comment.
Okay,
so
sure.
The bottom line is that the fundamentals of having the data in this graph format facilitates rapid development of the recommendation engine. And at runtime, the way the relationships in the data is also stored enables runtime efficiencies that make decision-making easier and faster. Have I got that correct? Yes.
That's an easy answer. Yes, that's actually that's absolutely correct. That's a very good summary. I think the only thing I'd add to that is to say that it's kind of almost a no regret way of doing things as well. In one of the issues in development over the past was, and one of the reasons that we ended up with agile development was that you didn't want to have to invest massive amounts of time before you could test something in the market and see whether it was any good. I believe that graph databases reflect that desire to do things quickly, but to be able to develop things quickly and then to be able to adapt them further without essentially having to start from the beginning and start from scratch. It's very easy to adapt graph databases according to the feedback that you get on the initial version of it. And I think that can help accelerate the process enormously.
Great. I don't see any other questions from the audience, but I wanted to point out something that I noticed and see if you want to add any comment. When you talk about the flexibility, looking at your example data graph with the context, it seems, maybe I think that illustrates very well the flexibility that rather than thinking in terms of a feature vector and some massive matrix or array where if you want to add another feature, you have to expand the columns of the table. Here, you just throw in another vertex and edges to whatever it should connect to. So it doesn't require any change to the schema. It's just adding a couple more objects as the data comes in. Is that a correct way to look at it?
Absolutely, it is. And I mean, we have some banner customers who use pretty much exactly those techniques. The one that we could mention is Wish.com, is one who operated enormous scale. And what they wanted was, because it's not their products, they're selling other people's products, it's a product platform, they have a huge turnover in products, very large scale turnover in products. So they need to be able to add new products very quickly. And the other thing they want to do is they want to respond to fashion in the market. So if it turns out that products are aimed at a particular market, say for example, they've got a tie-in with a movie. If you've got a movie tie-in with the Avengers, and then you want to add an Avengers feature, as you say, you can't be changing your schema, you can't be worrying about adding another column to an already 1,000-column matrix in order to do the work. You just want to be able to incorporate it. And this is something that this decomposition in a very natural way into features versus products allows you to do. And that gives them the agility they want at the sort of scale that they want as well, because efficiency is everything for them. They're a low-margin business, so they have to be very, very careful about what they do and how they do it. And they chose TigerGraph. They were big enough they could have built one themselves, but they tested us out. And fortunately for us, they decided that TigerGraph was the way to go. And they've been our customer ever since.
Great. I don't see any other questions. Did you have any final comments, or shall we wrap it up?
I think I've been talking about this to prospects for some time, and indeed some customers, and I know some of you are here, and thank you very much. I just thank you for attending. I hope this wasn't too repetitive for you. I think one of the things that we're getting an awful lot of discussion is about how do we support machine learning? How do we do that? Do we do machine learning inside the graph? And I think there's two parts to that answer, which is probably worth talking about. One is that because we automatically export an API that allows access to the database, if people have already got machine learning or AI systems set up in Python or in deep learning, whatever deep learning setup they've got, it's really easy to use the REST API to essentially feed it. And we talked about real-time feeding of data. That updating of weights in the feature set, that can be done by using your AI and your learning system. And that's something that's turning out to be extremely powerful. It allows people to take something that has been very much a theoretical exercise and essentially operationalize it. And I think that's a really good point, is to make the point that extension is actually quite easy to do. And the other side of it is, can you do machine learning inside the graph database? And that's a subject of particular interest to me right now, is what can we do? And I'm not going to get too heavily into the buzzwords around this. For example, my favorite subject at the moment is restricted Boltzmann machines, if you want to look something up and find out what weird world my head is in. It looks like we can, in fact, do some of this machine learning within a graph database because it looks like a graph. And again, we're in the unique position of being powerful enough and efficient enough to be able to do some limited machine learning type activities within the graph itself. And I think that's really exciting. And I'd love to find somebody who wanted that so I could talk about it. So I think that's the only thing I should add from the technology side. Just from a who I am and where I am side, we are just expanding into EMEA from the US. Obviously, if you're in the US and you're interested in this, please talk to my US colleagues. They're amazing. Their knowledge is just astonishing. Every day I learn something from talking to them. But if you're in EMEA, then you can get in touch with me directly, and I'd be delighted to talk you through this and maybe get into how could this work for you and how this could work as a product for you. I think that would be very exciting if that would come out of this presentation. Okay, there you go. End of the sale, Victor.
Thank you. We did get a couple last minute questions, which are a little bit more general, not specifically about recommendation, but so since we're all here and they were asked, I will try to answer them. First, how does TigerGraph avoid database locking in multiple streaming updates? Jen, do you want to try that?
Yeah. I can take it if you like.
Either way.
Okay, quickly I'll take it. Okay, and this is getting a little bit deep into database technology, but we are what is called an MVCC-based database. And what that means is that when we do an update, we essentially take a snapshot of the database at the time we do the update, and we provide those updates into the snapshot. So that means that any existing queries while that update is going on, they don't see it. They don't see that update happening until the update is complete, and then there is a very lightweight and very rapid change from the old snapshot to the new snapshot, so that any queries that happen after the transaction is completed then see the new snapshot. What this means is that reads do not block writes and writes do not block reads. And that is exactly how we, obviously there's a lot of complexity in making that work, but that is simply how it is that we allow writes without blocking reads.
Thank you.
I hope I got that right, Victor.
That was exactly correct. Yeah, so we actually do have a document in our documentation talking about our concurrency model. TigerGraph is an ACID compliant database, also designed for distributed computation. So distributed databases are require some special handling. Not all of them are ACID, but so we have an ACID compliant distributed database. There's a question about our roadmap and strategy for visualization. So as Richard showed you, we have our GraphStudio tool, which it's not just a graph visualization tool. It's a whole design desktop. So from graph modeling to data loading to ad hoc exploration, which is kind of what people think of when they think of graph visualization, as well as writing queries, which he was showing, and running them and then looking at the results. We also, it is also possible to connect to some outside graph visualization tools, but a lot of our customers are just using the GraphStudio right now. And the last question, which I think is back to you, do you recommend any document to look at this solution in a more detailed way? And actually, I think I can start off by saying we have something called Test Drive, testdrive.tigergraph.com, where we have several live systems which have example use cases and solutions with data and queries already loaded. And we are going to be making one for this very soon. But there are about 5 or 6 other test drives now which you can look at. So just go to testdrive.tigergraph.com. It'll ask you to register for the first time. And then you can, they are read-only because they are shared by everybody else that's looking at it. So you could be possibly using it at the same time that 100 other people around the world are using it. So you can run any of the existing queries, but you cannot alter things because that would, screw things up for the other users. So I guess I pretty much answered that. But
yeah, Richard, can you advance the slide so that we can share the links to all the resources?
Yeah, of course. I'll try and advance the slide. Ah, there we go. So that's the next one up is office hours. We have office hours every Thursday at 11 a.m. Pacific time, which is a fantastic way of being able to ask very detailed questions, particularly around implementation and the technology and how it works. The other resources are that there are many Graph Gurus guides already on the web, which talk about the other things that TigerGraph does. We do a lot more than just recommendation engines. I think the idea is, and tell me if I'm wrong, Emily, is that whether we can distribute a PDF version of this document to people. So on request, if you want to.
I shared the link.
Okay,
yeah,
fantastic.
The link is shared in the chat, but we'll also be emailing it later today.
Sure.
So you can get all the links.
And Victor mentioned Test Drive. The intention is if I can get there quickly enough, is to actually allow that to get this model, this simplified model and code up onto the test drive so that you can then play with it and maybe look at the code. And I think that will probably give you a lot of detail about what we're doing and why we're doing it. If you want to get into much more specific points, say if you've got specific questions, it's very easy to find me. Please just send me the questions and I'll either try and answer it or I'll definitely be able to point you in the direction of somebody who can answer the questions.
Yeah. So our next Graph Guru will be in a few weeks. I don't think we didn't put the date here, but I believe it's in
yeah, it's August 14th. Yeah, sorry.
Yeah. So that will be covering 7 key data science capabilities powered by a native parallel graph. And that will be presented by me and our head of our marketing vice president, Gaurav Deshpande. So we hope you can join us for that. And the final slide just gives you links to several other resources. I mentioned the test drive, the demo. You can download your own copy of the Developer Edition. Richard was using the Developer Edition on his laptop. We have a developer portal with lots of information resources for developers. All of the examples used in all of our 16 Graph Gurus are available online at GitHub. And again, like the office hours we mentioned, we also have an online discussion group. So if there's anything, if you're not seeing what you're looking for, we have chat right on our homepage of our website, and you can ask there, and we'll make sure that you get answers from the right person.